Today's lesson is on special right triangles. We're talking about isosceles right triangles, 45, 45, 90 degrees, and also 30, 60, 90 degrees right triangles. Our learning target, I will solve problems using properties of special right triangles. Take a moment, please, and write your essential question. A special right triangle is defined as a right triangle whose measures are 45, 45, 90 degrees, or 30, 60, 90 degrees. We have a couple of theorems. The 45, 45, 90 degree triangle theorem states that in a 45, 45, 90 degree triangle, the hypotenuse is the square root of 2 times as long as the length of each leg. Now look at this diagram for just a moment, and we've got a real problem with how this is written. The way this is written, it looks like x might be underneath the radical sign. This is from your textbook, and it's very poorly done. This should be written x square root of 2. The coefficient is always in front of the radical sign. The second theorem, 30, 60, 90 theorem, states that the hypotenuse is twice as long as the short leg, and the longer leg is square root of 3 times as long as the short leg. We have the same problem right here with how your textbook writes this. The coefficient should be in front of the radical, so fix that, please. Remember your triangle inequality side length theorem? So the shortest side has to be opposite the smallest angle. Hence, opposite the 30-degree angle is always the shortest leg in the 30, 60, 90 triangle. So the hypotenuse is twice the short leg, and the longer leg is square root of 3 times the short leg. Now, if you have a hard time remembering which one is which, my suggestion is to use your graphing calculator and just compare. Do the square root of 3, which is approximately 1.73201. 1.7 is less than 2. So the 60-degree angle has to be in the middle, and the 2, which is definitely going to be the longest side, has to be opposite the 90 degrees. Alrighty. Find the value of the missing links. So first and foremost, you have to identify what kind of triangle you have. Our first one here is a 45, 45, 90 degree. It's a right isosceles triangle. And that means my hypotenuse is 7 times the square root of 2. The next example is a 30, 60, 90. Now, I know that my hypotenuse will be twice the short leg, and the longer leg is going to be the short leg times the square root of 3. And that means I have an equation to solve here. 9 equals s times the square root of 3. Oh, look, radical rules. You know they make me happy. S equals 9 over the square root of 3. This violates the third rule of simplifying radicals. I have to multiply by the square root of 3 over the square root of 3. 9 square root of 3 over 3. Still not done, because the 9 and the 3 here can be simplified. The short side is 3 times the square root of 3. To find my longest side, I have to do 2 times the shorter side. 2 times 3 square root of 3 will be 6 square root of 3. That radicals gateway from the last quarter is going to come in handy. Our next triangle is a 45, 45, 90, which means x has to equal 4. That one was quick and easy. And y has to equal x times the square root of 2. So y equals 4 square root of 2. Next one on this page is a 30, 60, 90. Okay, A is the shortest side. It is opposite the 30-degree angle. That makes this side the longer side. That's A times the square root of 3. And B is my hypotenuse, so it's 2 times A. I need to solve this equation to figure out the value of A. And this one is sadly easy. A equals the square root of 10. And that means that B equals 2 times the square root of 10. Last example on this particular page, we have a rectangle with a diagonal. In this case, it has to be a 30, 60, 90. 15 is my short side. So my hypotenuse is going to be 2 times 15. And my longer side, since this is a rectangle, M, is going to be 15 square root 3. So just writing that nicely. M equals 30, and M equals 15 square root 3. All right, here is your practical application of special right triangles. The window is square. If the window is square, that means that this side and this side have the same length, x and x. We have our hypotenuse here, which is x times the square root of 2 in a 45, 45, 90 triangle. So x times the square root of 2 has to equal 36 times the square root of 2. X equals 36 inches. Okay, take a moment. There are 2 questions and a summary to write for this lesson.